Hello students and good morning. So now I am doing class for class 12 science. The topic is second order derivative. So in the last online class also we were doing the same topic, that is second order derivative. So we will do more problems on second order derivative. Okay. So this question number is 15. This is from the book. And after that we'll do questions from the previous year's question papers. That is from higher secondary question papers. Okay. So now let's do this question number 15 from the book. Same exercise 4, page number 323. This is 5 marks section from the book Higher Mathematics for class 12 by Sailendra. So let's start this question number 15 now. So if y is equal to within square root sin x plus within square root sin x plus within square root sin x plus dot 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 to infinity, what does it mean? It is given that y is equal to within square root sin x plus within square root sin x plus within square root sin plus sin x plus again within square root there is sin x plus again within square root sin x plus again within square root sin x plus, which goes up to infinity. It never ends. Clear? So you have to prove that. अब हामीले चाहिँ यहाँ के प्रुभ गर्नुपर्छ भन्दाखेरि 2y minus 1 whole cube into d2y by dx square is equal to minus, you have to prove this right hand side, that is minus within third bracket 2 into y square minus y whole square plus y square minus y plus 2. You have to prove this LHS is equal to RHS from given. Okay, so now let us write down this given. So here given is y is equal to root over sin x plus root over sin x plus root over sin x plus dot dot dot, it goes up to infinity, which never ends. Okay, now we have to square both the sides. Squaring both the sides गर्दा फेरि यो बाहिरको यो फर्स्ट स्क्वायर रुट चाहिँ एलिमिनेट हुन्छ. If you square both the sides on the right hand side, this first square root will be removed. Okay, if you square both the sides. Okay, so let's simplify it by squaring both the sides. So squaring both the sides. Okay, हामीले यहाँ के गर्दैछौं, हामीले both side लाई squaring गर्दैछौं. The left hand side के भयो, y square is equal to the right hand side बाट first को square root चाहिँ eliminate हुन्छ squaring गर्दा. That means what do we get? Sin x plus again there is root over sin x plus again within square root there is sin x plus again within square root there is sin x plus, which goes up to infinity. So I think you have understood it. Okay, बुझ्यो सबले यो. त अब हामी के गर्न सक्छौं, यो सेकेन्ड टर्म जुन चाहिँमा चाहिँ स्क्वायर रुट छ यसको सट्टामा हामी के लेख्न सक्छौं, अगेन यु क्यान पुट y आउट हियर, बिकज स्क्वायर रुट अफ sin x plus square root of sin x plus square root of sin x plus square root of sin x, which goes up to infinity, that is equal to y. So instead of this, from the second term we can write y. So or y square is equal to, this is sin x, this is your sin x plus what you will write it for, you can write it y for this square root, that is square root of sin x plus square root of sin x plus square root of sin x plus dot 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 to infinity. So I think you have understood it. Now we will differentiate it with respect to x. Before that, you take plus y to the left hand side. The differentiation गर्नु अगाडि यो प्लस y लाई हामी कता लान्छौं, लेफ्ट साइडमा लान्छौं. So it is therefore y square minus y, isn't it? So y is taken to the left hand side, becomes minus y, which is equal to sin x. Is that clear now? Now let's find out dy by dx. That is, you differentiate both the sides with respect to x. So differentiating both the sides with respect to x. Okay. So what is the differentiation of this? What is the differentiation of y square with respect to x? What is it? or it is 2y into dy by dx minus, again differentiate y with respect to x, that is your dy by dx, which is equal to, now differentiate sin x with respect to x, which is equal to cos x. So I think you have understood it. So from here, let us find out the value for dy by dx. Let us solve for dy by dx. You can get the value for dy by dx. So what is common here now? So dy by dx taken common within bracket 2y minus 1 is equal to cos x. Okay. Now let's get the value for dy by dx, or what is dy by dx is equal to, this is your cos x divided by 2y minus 1. So let us mark it as number 1. Now you have to prove the value for d2y by dx square. So again, what will you do? Again, you have to differentiate both the sides with respect to x. Okay. So now let us differentiate both the sides with respect to x. So again, differentiating both the sides with respect to x. Again, differentiating both the sides with respect to x. So therefore, it is d2y by dx square is equal to, now both are the variables here on the right hand side. Numerator is cos x, that is a variable. 2y minus 1, that is a variable also, which is in the denominator. So now when you differentiate both the sides with respect to x, on the right hand side you have to use u by v rule. You know u by v rule. So let's differentiate cos x divided by 2y minus 1 with respect to x. We have to use u by v rule. Okay. Now here 2y minus 1 is denominator is kept as it is, into, now take the differentiation of the numerator, which is minus sin x, then comes minus sin. Now cos x is kept as it is, now into, now take the differentiation of the denominator with respect to x. So what is it? 2 into dy by dx, and for minus 1 it is 0, you don't have to write it. So whole divided by, what is there? Denominator whole square, which is 2y minus 1 whole square. So is that understood now? So you can copy it. So now again you have to simplify it further. Now here, so let us cross multiply. 2y minus 1 whole square like cross multiply garnu, or this is 2y minus 1 whole square into d2y by dx square, which is equal to, now this is, there is minus sign, minus comes in the front, minus la agadi lekhne. So 2y minus 1 into, now again in this case you can put the value for sin x. Actually what was sin x? From this given, sin x is equal to y square minus y, isn't it? Let us write here y square minus y. Clear? Then write down minus, let's write 2 first, then write down cos x into, again what is the value for dy by dx? Again you can put the value for dy by dx from here, that is, it is cos x divided by, this is 2y minus 1. So I think you have understood it. Okay, so copy it. So in the next step, what will you do? Now let us take the LCM on the right hand side. Okay, हामी यो right hand side मा के गर्छौं? LCM निकाल्छौं. त अब हामी LCM निकाल्छौं. त तिमीले यो पनि लेखिराख्नु है. You have to prove this result. Okay, that is minus within third bracket 2 into y square minus y whole square plus y square minus y plus 2. That is minus within third bracket 2 into y square minus y whole square plus y square minus y plus 2. त यसलाई हामी हेर्दै गर्दै जानुपर्छ अनि मात्रै यो प्रुभ हुन्छ हैन. त्यसरी नै यसलाई हामी सिम्प्लिफाई गर्दै जान्छौं. ठीक छ. So now take the LCM on the right hand side. So what's the LCM now? Now what's the LCM out here? So, or this is your 2y minus 1 whole square into d2y by dx square, which is equal to, on the right hand side, what's the LCM? This is your 2y minus 1 is the LCM. Okay. So below this expression there is 1 and this is your LCM. 2y minus 1 is divided by 1. That means you will get 2y minus 1 and it should be multiplied by minus 2y minus 1 into y square minus y. So that is minus 2y minus 1 whole square, then y square minus y square minus y, then minus 2 into, what is cos x into cos x? That is your cos square x. Is that clear to all of you? So I think you have understood it. Okay. So next. So let us simplify it further now. Now you can do cross multiplication. 2y minus 1 whole square into 2y minus 1. That is your 2y minus 1 whole cube. So it is d2y by dx square is equal to. So we have got this left hand side, isn't it? So is equal to minus 2y minus 1 whole square into y square minus y minus 2 into cos square x is there. So you have to eliminate this cos square x also, since we know the value for sin x, isn't it? We know the value for sin x. What was the value for sin x? It was y square minus y, isn't it? Sin x was y square minus y. Isn't it? We have simplified given and we got the value for sin x, which was y square minus y, isn't it? So let us convert it into sin square x form. That is your 1 minus sin square x. Is that clear? So, or this is your 2y minus 1 whole cube. This is d2y by dx square. Let us simplify this right hand side. Minus 2y minus 1 whole square into y square minus y. Next, multiply by minus 2 here. Minus 2 minus into minus plus. This is your 2 sin square x. Understood now? So now let us simplify it further now. You know the value for sin x, isn't it? So from given we got sin x is equal to y square minus y. So instead of sin x you can put y square minus y there. So or this is your 2y minus 1 whole cube into d2y by dx square, which is equal to minus 2y minus 1 whole square into y square minus y minus 2 plus 2 into, what is sin x actually? It is y square minus y. That is whole square, because whole square is there, isn't it? So you have to prove this result. That is, you have to prove that. What is to be proved? I will write it here. You have to prove that 2y minus, that is 2y minus 1 whole cube d2y by dx square is equal to minus, within third bracket 2 into y square minus y whole square. Then it was I think plus y square minus y plus 2, isn't it? You have to prove this result, I think. So let us check it from the book. It was page number 223, I think, or 322. So you have to prove that minus within third bracket 2 into y square minus y whole square plus y square minus y plus 2, yes. So that that is the expression to be proved on the right hand side. Okay. So now you have to simplify it again. So let us simplify this right hand side. Okay. So or this is your 2y minus 1 whole cube into d2y by dx square is equal to, let us expand it, minus within first bracket. This is your a minus b whole square. You know a minus b whole square, a square minus 2ab plus b whole square. So it is 4y square minus 4y plus 1, right? Then y square minus y is there, minus 2 plus 2 into, again this is the form. So what is this form now? A minus b whole square again. So again, what is a minus b whole square? Let us expand it again. This is your y to the power 4 minus twice ab. That is your twice y cube plus y square. Is that clear? Now let's simplify it further. We can simplify again the right hand side. You can multiply them. or this is your 2y minus 1 whole cube into d2y by dx square, which is equal to, now multiply them, minus within bracket 4y square into y square, 4y to the power 4 minus 4y cube. We are multiplying them, you know how to multiply it, isn't it? 4y cube minus 4y cube. Again, this is minus, yes, right, minus 4y cube. This is also minus 4y cube. This is minus 4y cube. Minus into minus plus 4y square. 4y square, then plus y square minus y. Plus y square minus y. So minus sign is there. We are multiplying these two factors. It is 4y to the power 4 minus 4y cube minus 4y cube plus 4y square plus y square minus y, right? So minus 2 plus, now multiply by 2 there. It is 2y to the power 4. 2y to the power 4 minus, that is your 4y cube. This is your minus 4y cube, right? Then plus 2y square. Plus this is your 2y square. So I think you have understood it. Okay. Now again you can simplify it further now. So, or this is 2y minus 1 whole cube. This is your d2y by dx square is equal to, now multiply by minus sign here. So this is minus 4y to the power 4. Okay. This is minus 8y cube. So minus into minus plus, this is your 8y cube. This is your plus 5y square. So there is minus sign, minus 5y square. Minus into minus plus, this is your y. Okay. So next, minus 2 plus 2y to the power 4 minus 4y cube plus this is your 2y square. Now again you can simplify it further now. In order to prove this relation, you have to simplify it further. So, or this is your 2y minus 1 whole cube into d2y by dx square is equal to, now this is minus 4y to the power 4. This is the only expression there, y to the power 4, that is minus 4y to the power, there is another expression is also there, that is minus 4y to the power 4 plus 2y to the power 4. What is that? Minus 2y to the power 4. Minus 2y to the power 4. Now you can simplify the term containing cube, minus 8y cube plus 8y cube minus 4y cube. Plus 8y cube minus 4y cube. What is that? Plus 4y cube. Then simplify the term containing square, minus 5y square plus 2y square, that is your minus 3y square. Is that clear now? Then you can write down plus y, then minus 2. Okay. Now this is y to the power 4, y cube, y square, y minus 2. Now you have to simplify it in such a way that we can prove this right hand side. Okay. Now here what will you do here is that since you have to prove y square minus y plus 2, we can break this term minus 3y square. So how can you break this term? You can write it as minus 2y square minus y square in order to prove 2 into y square minus y whole square plus y square minus y plus 2, right? So, or this is your 2y minus 1 whole cube into d2y by dx square, which is equal to minus 2y to the power 4 plus 4y cube. Then you can write down this term as minus 2y square minus y square, isn't it? So that we can simplify these first three terms. Okay. If you write minus 2y square minus y square, we can simplify these first three terms. Then you have to write minus y square, so that minus 2y square minus y square is minus 3y square. Is that understood? Then plus y minus 2. Then plus y minus 2. ठीक छैन यो? लो अब हामी यसलाई सिम्प्लिफाई गर्छौं फेरि. From the first three terms, what is common there? Or this is your 2y minus 1 whole cube into d2y by dx square is equal to minus, here minus is taken common, right? So minus 2 is taken common, here 2 is common, only you take 2 common here, okay? not y. You take only 2 common here. So within bracket, what do we get? Y square minus 2y cube plus y square. Is that clear? Here minus 2 is common from the first 3 terms. Minus 2 into y to the power 4 minus 2y cube plus y square. Then this is minus y square plus y minus 2. Is that clear now? So you can copy it. So now let's do the further simplification. So we have to prove this result, okay? Or this is your 2y minus 1 whole cube d2y by dx square is equal to minus 2, now within third bracket here. Now convert it into the form of a square minus 2ab plus b whole square. That is, you just write down the bracket, only the bracket, you write only brackets here, a square, then minus twice ab plus b whole square. Okay, since y to the power 4 is there, you have to write here y square. Since y square is there, you have to write y here. This is the place for a. What is the value for a here? Y square. This is the place for b. What is the value for b here? This is y. So we are getting this middle term also, minus 2y cube. This is also minus 2y cube. So we have expressed it in the form of a square minus 2ab plus b whole square. Then write down the last 3 terms, minus y square plus y minus 2. Understood? So next, so let us simplify it further. Or this is your 2y minus 1 whole cube. This is your d2y by dx square is equal to minus 2. Now what is the formula here? A square minus 2ab plus b whole square. What is the formula? It is y square minus y whole square. Okay? Then minus y square plus y minus 2. ठीक छ नि यहाँसम्म? So अब हामी उते प्रुभ गर्न सक्छौं, तर हामी के कमन निकाल्छौं? Minus is taken common now. So if you take minus common, you will get that right hand side. Okay? So or this is your 2y minus 1 whole cube d2y by dx square. Only minus sign is taken common. So within third bracket, write down all the expression within third bracket. If minus sign is taken common, all the sign inside the bracket will be changed. So 2 into, this is y square minus y whole square, minus into minus, plus y square, minus into plus, minus y, minus into minus, plus 2. That is, which is equal to right hand side. So we have proved it. So I think you have understood it. So you can copy it. Now we'll do questions from higher secondary question papers. Okay? So you can copy it. So now we will do questions from Madhyamik, not Madhyamik. We will do questions from higher secondary question papers. That is, this question is from not Madhyamik Pariksha. This is HS 2015. This is higher secondary 2015. So we have almost completed problems from the book. So now let's start from the previous year's higher secondary question papers. And this question is from higher secondary 2015. That is, this question is from number 2C number 1. If x is equal to 2 cos theta minus cos 2 theta and y is equal to 2 sin theta minus sin 2 theta, then you have to find out the value of d2y by dx square at theta is equal to pi by 2. You have to get the value for d2y by dx square when theta is equal to pi by 2. And you know that these x and y are expressed in terms of a third variable theta. Here theta is a parameter. So this type of equation is known as parametric equation. So first of all, you have to get the value for dx by d theta. So here given is x is equal to 2 cos theta minus cos 2 theta. Now differentiate both the sides with respect to theta here. So differentiating both the sides with respect to theta. So therefore dx by d theta is equal to, what is dy dx of cos theta? 2 is constant. 2 into, what is the differentiation of cos theta with respect to theta? Minus sin theta minus, now what's the differentiation of cos 2 theta? First of all, it is minus sin 2 theta. It is cos को differentiation के हुन्छ minus sin x, again differentiate 2 theta with respect to theta, that is into 2. So or this is dx by d theta is equal to, now this is minus into minus plus, okay, here 2 is common, 2 is taken common, within bracket what do we get? This is your sin 2 theta, that is positive term is written first and then write down minus sin theta. So let us mark it number 1. So this is your dx by d theta. Now let us find out dy by d theta. Again, what is given here? Again, what is y here? Y is equal to 2 sin theta, 2 sin theta minus sin 2 theta. It is 2 sin theta minus sin 2 theta. So let's differentiate both the sides with respect to theta now. So differentiating both the sides with respect to theta, okay. So therefore this is dy by d theta is equal to, now 2 into, what is the differentiation of sin theta with respect to theta? That is your cos theta. So 2 remains same, cos theta minus, now differentiate sin 2 theta with respect to theta. What is it? It is cos 2 theta into 2. Again, what is common here? 2 is common here. So or dy by d theta is equal to 2 is common here. So within bracket we have, this is cos theta minus cos 2 theta. Is that clear? So this is number 2. So now what will you do with this 1 and 2? To get dy by dx, we can divide it. So dividing 2 by 1. So dividing 2 by 1. So what do we get dividing 2 by 1? Therefore dy by d theta upon dx by d theta, which is equal to, on the right hand side what will be there? It is 2 into cos theta minus cos 2 theta divided by, in the denominator write down right hand side of number 1, what is it? It is 2 into sin 2 theta, then minus sin theta, so here 2 gets cancels. So also you can cancel d theta and d theta from both the numerator and from both the numerator and the denominator. So you will get dy by dx only. So write down, so therefore dy by dx is equal to, so therefore in the next step you can get the value for dy by dx, which is equal to, it is cos theta minus cos 2 theta divided by sin 2 theta minus sin theta. Is that clear to all of you? So now in order to differentiate it again with respect to x, because you have to get d2y by dx square, you first simplify this right hand side. You can use a formula here from trigonometry. In class 11 you did transformation of products and sums, isn't it? So in the numerator you can use the formula cos c minus cos d. So what is the formula for cos c minus cos d? So it is 2 sine of c plus d by 2 sine of d minus c by 2. You should know this formula. Cos c minus cos d is equal to 2 sine of c plus d by 2, then sine d minus c by 2. Okay. Then down here in the numerator there is sine c minus sine d. So what is sine c minus sine d? 2 cos of c plus d by 2. 2 cos of c plus d by 2, then comes sine of c minus d by 2. So we will use these two formulae in order to simplify that right hand side. Okay. So now let us simplify this right hand side. Okay, so let us simplify this right hand side now. Or this is dy by dx is equal to, this is cos c minus cos d. What is the formula? 2 sine of, what is c plus d? Theta plus 2 theta divided by 2. That is your sine c plus d by 2. Then write down sine of d minus c. What is d minus c? 2 theta minus theta divided by 2. Whole divided by. Whole divided by, in the denominator, what will you write? What is sine c minus sine d? It is 2 cos of c plus d. That means here c is 2 theta plus d theta, that is d divided by 2, into sine of c minus d by 2, that is 2 theta minus theta divided by 2. Is it clear now? So here this 2 will be cancelled. You can cancel them. Or this is your dy by dx is equal to, now here you can cancel this term, you can cancel it. Sine of 2 theta minus theta by 2, you can cancel them, which is equal to sine, this is 3 theta by 2 divided by, this one is cos 3 theta by 2. I think you have understood it. So what is sine by cos again? It is sine by cos is tan theta. So dy by dx is equal to, what is it? It is tan theta by 2, tan 3 theta by 2. Is that clear? Now again you have to differentiate both the sides with respect to x in order to get the value for d2y by dx square. Okay, so now again differentiating both the sides with respect to x, but this right hand side is the function of theta. Theta is a parameter, but you have to differentiate both the sides with respect to x. So differentiating both the sides with respect to x, right? So differentiating both the sides with respect to x, what do we get now? It is d2y by dx square is equal to, so how will you differentiate this right hand side? Let us take it as tan x. What is the differentiation of tan x? It is sec square x, but what is x here? 3 theta by 2, so it is sec square, what is x here? It is 3 theta by 2 into, again you have to differentiate the term which is assumed as x. हामीले यहाँ कुन चाहिँलाई x माने लिएको हो? 3 theta by 2. यसलाई फेरि हामी डिफरेन्शिएट गर्छौं with respect to x into, what do we write? d by dx of what? 3 theta by 2. किनभने यसमा हामीले x केलाई माने लिएको हो? 3 theta by 2 लाई, त त्यसलाई फेरि डिफरेन्शिएट गर्नुपर्छ with respect to x. That means d by dx of 3 theta by 2. Okay, so or it is d2y by dx square which is equal to sec square 3 theta by 2 into, now differentiate 3 theta by 2 with respect to x, so it will be 3 by 2 into d theta by dx. 3 by 2 is constant, you can keep it as it is, into take the differentiation of theta with respect to x, that is d theta by dx. Okay, so or now this is d2y by dx square which is equal to, now this is 3 by 2 into sec square 3 theta by 2 into, what was d theta by dx? Actually what will be d theta by dx? We have calculated it, that is number 1. You can check that number 1. Actually it was 3 theta by 2 is written here in the front, and what is the value for d theta by dx? There was dx by d theta. Dx by d theta was 2 within bracket sine 2 theta minus sine theta, isn't it? Sine 2 theta minus sine theta. That was your dx by d theta. But what is d theta by dx? It will be 1 upon, it will be inverted, right? It will be 1 upon 2 into within bracket, it will be sine 2 theta minus sine theta. So I think you have understood it. That is d theta by dx. That is d theta by dx. Actually dx by d theta was 2 into sine 2 theta minus sine theta. But what is d theta by dx? You have to invert it. So it is 1 upon 2 into within bracket sine 2 theta minus sine theta. So we have got this expression. That is the expression for what? It is d2y by dx square. Okay. But in this case, you have to get the value for d2y by dx square when theta is equal to pi by 2. Now in this case, you can put the value for theta which is equal to pi by 2. So putting theta is equal to pi by 2. So let us put it now. So it is d2y by dx square, d2y by dx square is equal to 3 by 2 sec square within bracket 3 by 2 into what was theta? It is pi by 2, right? Into 1 upon 2 into within bracket sine 2 into what is theta here? Pi by 2 minus sine instead of theta, what will you put? It is pi by 2. So I think you have understood it. Okay. So now let us put the value now, which is equal to 3 by 2. This is your sec square 3 pi by 4. It is sec square 3 pi by 4 into 1 upon 2 into this is your sine pi minus this is your sine 90. That is sine pi by 2. Is that clear to all of you? So now let us get the value for sec 3 pi by 4. You should know the value for sec 3 pi by 4, which is equal to sec. What is 3 pi by 4 in terms of degree? This is in terms of radians. You have to convert into sexagesimal system. That means in terms of degrees. So pi by 4 is 45. 45 into 3 is 135 degree. Which is equal to sec 180 degree minus 45 degree is 135 degree. You can write it as 180 minus 45. So which is equal to, you know that sec 180 minus theta. 180 minus theta lies in the second quadrant. In the second quadrant, sec is always negative. And since 180 is 90 into 2, even multiple 90, so sec remains as it is. So it is minus sec 45. Minus sec 45, which is equal to minus, what is the value for sec 45? It is root 2. Is that clear? So what is the value for sec 3 pi by 4? It is minus root 2. Is that clear now? So let us put the value now. So we have just found out the value for sec 3 pi by 4. So therefore d2y by dx square, d2y by dx square is equal to 3 by, this is 2 to the 4. So 3 by 4. What is the value for sec 3 pi by 4? It is minus root 2. So it is minus root over 2 whole square into, right, 1 upon. So we have already written this 2 with this 2, that is 4, right? What is sine pi? You know that sine n pi is always 0 wherever n is any integer. That means sine pi is always 0. 0 minus 1. So what is the value for sine pi by 2? That is always 1. So, or this is your d2y by dx square is equal to 3 by 4 into, what is minus root 2 whole square? Minus into minus plus root 2 whole square is 2 into 1 upon minus 1. So 2 1s are 2, 2 2s are 4. So what is the final answer in this case? So d2y by dx square is equal to, this is your minus 3 by 2. So this is the final answer. So this question carries 4 marks. So it's very, very important. Okay. Now we'll do next question now. So now we'll do question from HS 2017, that is question number 2C number 1. If P square is equal to A square cos square theta plus B square sin square theta, then you have to prove that P plus d2P by d theta square is equal to A square B square divided by P cube. So you have to prove this relation. Okay, so let us prove it now. So here, what is given here? Here given is P square is equal to A square cos square theta plus B square sin square theta. So let us differentiate both the sides with respect to theta in order to get dp by d theta first. So differentiating both the sides with respect to theta. So what is the differentiation of p square with respect to theta? It is 2p into dp by d theta is equal to a square is constant, it is kept as it is. What is the differentiation of cos square theta? It is 2 cos theta into, and differentiation of cos theta is minus sin theta with respect to theta, plus b square into, what is the differentiation of sin square theta? It is 2 sin theta cos theta. It is 2 sin theta first, then again differentiate sin theta with respect to theta, which is cos theta, right? So, or this one is 2p into dp by d theta is equal to, this is minus sin a square. Now what is 2 sin theta cos theta? This is your sin 2 theta, plus similarly here b square into, what is 2 sin theta cos theta? It is sin 2 theta. This is your sin 2 theta, right? So, or 2p into dp by d theta is equal, you can take common here. Here sin 2 theta is common. So within bracket you write on positive term first, b square minus a square into sin 2 theta, right? So, or what is dp by d theta now? So dp by d theta is equal to b square minus a square by 2 is constant into, this is your sin 2 theta divided by p. So here we have separated this constant and variable. So since p and theta are variable here, in this case you have to find out d2p by d theta square. So p and theta are the variables here and all other terms are constant. That means b square minus a square by 2 is constant and this sin 2 theta divided by p is the variable. Again you have to differentiate it. So while differentiation, you have to use u by v rule here, because both the numerators and the denominators are the variables. Okay. So now again differentiating both the sides with respect to theta. Again we are differentiating both the sides with respect to theta here. So therefore d2p by d theta square is equal to, now here this is constant, b square minus a square by 2 is kept as it is. Now within third bracket you have to use u by v rule, isn't it? So in this case denominator is kept as it is, p is kept as it is, p into, what is the differentiation of sin 2 theta with respect to theta? What is the differentiation of sin 2 theta with respect to theta? That is, it is cos 2 theta into 2. Is that clear? Then comes minus sign, then sin 2 theta is kept as it is, sin 2 theta is kept as it is into, now take the differentiation of denominator with respect to theta, that is your dp by d theta, whole divided by, this is your denominator whole square. What is denominator whole square? This is your p square. So I think you have understood it. Okay. Or this is your d2p by d theta square is equal to b square minus a square by 2 within third bracket now. Now you have to simplify it further. So now it is 2p into cos 2 theta, right? It is 2p into cos 2 theta. I think you have understood it. So minus sin 2 theta into, what is dp by d theta? Just now we have got it. What is dp by d theta? It is this one. You can put the value for dp by d theta there. So minus sin 2 theta into, what is dp by d theta? It is b square minus a square. Now this is sin 2 theta whole divided by 2p, whole divided by 2p. Is that clear now? So I think you have understood it. This whole divided by, this is your p square. So you can copy it. So now we will simplify it now. Now in the next step, you can take the LCM in this case. Okay. So, or this is your d2p by d theta square is equal to. So now this is your b square minus a square by 2, and within third bracket, what's the LCM in the numerator? This is your 2p, right? 2p is the LCM. So 2p into 2p, that is your 4p square. Then you have to write down cos 2 theta. Okay. Then what will you write? Minus b square minus a square, b square minus a square, sine 2 theta into sine 2 theta. What is it? This is your sine square 2 theta. This is your sine square 2 theta. So this whole divided by 2p is there into, so below p square there is 1. So when it goes up in the numerator, it becomes 1 upon p square, isn't it? It is 1 upon p square. So here third bracket is closed. So I think you have understood it. So now let us simplify it further. Okay. So you can copy it. So now let us simplify it further, or d2p by d theta square, which is equal to, now it is b square minus a square by 2. It is kept as it is. Now within third bracket, let us simplify it further, right? So 4 into, what is p square actually? From given you can put it. What is the value for p square? A square cos square theta plus b square sin square theta. I think you have understood it. Next, what is cos 2 theta formula? It is cos square theta minus sin square theta. You know this formula from multiple angles. Is that clear? And next one is minus b square minus a square. And what is sine 2 theta? That is your sine 2 theta whole square. So what is the formula for sine 2 theta? 2 sine theta cos theta. This is your whole square. Okay. B square minus a square is kept as it is. Now you know the formula of sine 2 theta, which is 2 sine theta cos theta whole square. So this whole divided by, what can you write? 2p into p square. That is your 2p cube. Your third bracket is closed. So I think you have understood it. Okay. So now let us simplify it further. Or this is d2p by d theta square is equal to b square minus a square divided by, this is 2 2's are 4p cube. You can write it here, 4p cube. Now let us simplify the numerator now. So this is your 4. You can multiply these two factors and multiply it by 4. What do we get? 4a square. This is cos to the power 4 theta minus 4a square sin square theta cos square theta plus 4b square sin square theta cos square theta, plus and minus, right? So it is 4b square minus 4b square sin to the power 4 theta. It is sin to the power 4 theta. Is that clear to all of you? So last one is minus. There is b square minus a square. Write it, b square minus a square within bracket. It is b square minus a square. Then what is 2 sin theta cos theta whole square? That is your 4 sin square theta cos square theta. Is that clear? So this 2p cube is written out here. 2 to the 4p cube, right? So here third bracket is closed. Now let us simplify it further again. So let us simplify it further again. So what will you do now? Or now this is your d2p by d theta square right? Then write down which is equal to b square minus a square divided by 4p cube. So within third bracket, let us simplify it, right? So now keep the first four terms as they are. 4a square cos to the power 4 theta minus 4a square sin square theta cos square theta plus 4b square sin square theta cos square theta. Then next minus 4b square sin to the power 4 theta. Now multiply it. So it is minus 4b square sin square theta cos square theta, right? Minus to minus plus 4a square sin square theta cos square theta, 4a square sin square theta cos square theta. Third bracket is closed. So I think you have understood it. So you can copy it. So now again you have to simplify it further. So can you cancel any term here? This minus 4a square sin square theta cos square theta plus 4a square sin square theta cos square theta will be cancelled. Next, plus 4b square sin square theta cos square theta and minus 4b square sin square theta cos square theta will be cancelled. Okay. So now, or d2p by d theta square is equal to b square minus a square divided by 4p cube into. So we can take common out here. So what is common here? 4 is common. Within bracket, what do we get? A square cos to the power 4 theta minus b square. This is your sin to the power 4 theta. So again you can cancel this 4 here. You can cancel that 4. You can cancel it. Okay. So now write down remaining terms. So now what are the remaining terms here? Or d2p by d theta square, d2p by d theta square is equal to, now you can multiply it. You can multiply it. That is a square b square cos to the power 4 theta minus b to the power 4, right? Minus b to the power 4 sin to the power 4 theta. Next, minus a to the power 4 cos to the power 4 theta, okay, and minus into minus plus a square b square minus into minus plus a square b square sin to the power 4 theta. It is sin to the power 4 theta. So this whole divided by, what will you write here? This is your p cube. So I think you have understood it. Okay. Now let us simplify it further now. Or this is d2p by d theta square, which is equal to, now from first and last term, what is common there? It is a square b square, isn't it? So within bracket, what do we get? It is cos to the power 4 theta plus it is sin to the power 4 theta. Is that clear? And from this second and third, what is common? Minus is taken common. So within bracket, what do we get? B to the power 4 sin to the power 4 theta plus a to the power 4 cos to the power 4 theta. This whole divided by, this is your p cube. So I think you have understood it. Okay. Now let us simplify it further. So now here you can use the formula. Which formula is used out here? Cos to the power 4 theta plus sin to the power 4 theta is there. So let us keep it as it is now. We can use the formula here. This is your a square plus b square. So we can use your a square plus b square formula. That is a plus b whole square minus 2ab. You know that, isn't it? That is, you know, a square plus b square, which is equal to a plus b whole square minus 2ab. We can use this formula, right? So, or this is your d2p by d theta square is equal to, this is a square b square within bracket, keep it as it is now, cos to the power 4 theta plus sin to the power 4 theta, right? And this one will be minus within second bracket b square sin square theta whole square plus a square sin square theta whole square, second bracket closed, whole divided by this is your p cube. Understood? Next, so next one is or d2p by d theta square, d2p by d theta square is equal to, now this is your a square b square within bracket cos to the power 4 theta plus sine to the power 4 theta. Okay, next, this is your a square plus b square. We can use this formula, a plus b whole square minus 2ab, isn't it? So minus sine within second bracket, this is your a plus b whole square. What is a plus b whole square? A means b square sin square theta plus b means a square cos square theta whole square. Then minus twice ab. What is minus twice ab out here? What is minus 2ab here? Minus 2b square sin square theta into a square cos square theta. Second bracket is closed. Second bracket is closed. So this whole divided by what can you write? P cube. We can write P cube. Okay? So now again you can simplify it further, or this is your d2p by d theta square is equal to a square b square, let us keep it as it is, cos to the power 4 theta plus sine to the power 4 theta minus within second bracket. Now you tell me, what is b square sin square theta plus a square cos square theta from given? It is p square. So we can write here p square whole square minus, so now this will be 2a square b square sin square theta cos square theta. Second bracket is closed, whole divided by this is your p cube. Is that clear? Next, or d2p by d theta square is equal to, now it is kept as it is, a square b square within bracket cos to the power 4 theta plus sine to the power 4 theta. So multiply by minus sign here, minus p square whole square is p to the power 4 minus to minus plus. Okay, then 2a square b square, then sine square theta cos square theta, this whole divided by p cube, whole divided by p cube. Okay, so you can copy it. So now in the next step we can use the formula again here, that is first of all you have to take common from the first and the last term. What is common? A square b square is common out here, isn't it? So let us take it outside common. So let us write here, or d2p by d theta square is equal to, now a square b square is taken common from the first term and the last term. Okay, so this is cos to the power 4 theta, right? This is cos to the power 4 theta plus sine to the power 4 theta plus this is your 2 sine square theta cos square theta, right? So from the first and the last term, what is common here? A square b square. Then write down minus p to the power 4. This whole divided by what? Whole divided by p cube. Understood? So now in the next step, what will you write? d2p by d theta square is equal to a square b square into, now this is the formula, a square plus b square plus twice ab. What is the formula here? A plus b whole square, that is your cos square theta plus sin square theta whole square, then minus p to the power 4 whole divided by this is your p cube. Understood? Right? So what is cos square theta plus sin square theta? That is always 1. So, or this is your d2p by d theta square will be equal to a square b square, and since this is 1 whole square, that is 1, you don't have to write it, then minus p to the power 4 divided by p cube. Understood? Now you can split the term here, or d2p by d theta square is equal to, split the term on the right hand side, what do we get? A square b square divided by p cube, then minus. So this term is separated. That is a square b square upon p cube minus p to the power 4 by p cube, that means p. P to the power 4 divided by p cube bhaneko कति भयो? P bhayeko. So now minus p is taken to the left hand side in order to prove the required relation. So or this is your p plus d2p by d theta square, which is equal to, on the right hand side, what do we write? This is a square b square divided by p cube. So it is done. So it is proved. So I think you have understood it. So you can copy it. So this is quite complicated problem, but you have to practice it at home, so it will be easier for you to simplify it. Okay, त घरमा जति प्र्याक्टिस गरे त्यति सजिलो हुँदै जान्छ. सो अब म तिमीलाई होमवर्क दिन्छु, ठीक छ, फ्रम द हायर सेकेन्डरी क्वेशन पेपर्स. So now these are your homework from the previous year's question papers. That is from, this is from HS 2016. 2C number 1 is, if PV to the power A is equal to C, then you have to prove that V square into D2P by DB square is equal to A into A plus 1 into P. So this is your homework, you can do it. Okay, this is from HS 2018. We have done HS 2017 and HS 2015. Okay, so HS 2018 is your homework. That is 2C number 1 is, if y is equal to sin inverse x divided by root under 1 minus x square, then you have to show that within bracket 1 minus x square into d2y by dx square minus 3x divided by dx minus y is equal to 0. I will not give you the hint, you have to do yourself. Okay, so this is also your homework. That is HS 2019. This is also 2C number 2 question. If x is equal to sin t, y is equal to sin kt, these are this is parametric equation. You have to show that 1 minus x square into d2y by dx square minus x divided by dx plus k square y is equal to 0. So here k is a non-zero constant. Okay, so this is from HS 2020. This is 2C number 1. If y is equal to tan inverse x whole square, then prove that 1 plus x square whole square d2y by dx square plus 2x into 1 plus x square into dy by dx is equal to 2. So you can do this problem also. This is from this year, that is HS 2020. So यो चारटा problem छ, तिमीले घरमा राम्रोसँग गर्नु. You can do it. Okay, so now this much is for today. त आज हामीले जति पनि प्रब्लमहरु गर्यौं सबै अलिक अप्ठ्यारो नै थियो. त्यो घरमा तिमीले राम्रोसँग प्र्याक्टिस गर्नु, यसलाई रिपिट गर्नु, घरि रिपिट गर्नु यो प्रब्लम्सहरुलाई, किनभने आज हामीले जुन चाहिँ गर्यौं अलिकति कम्प्लिकेटेड प्रब्लम नै थियो. बुझ्यौ? So this chapter is finished. This is second order derivative. This chapter is finished, and in the next class we'll do the new chapter, that is relations and functions. So यो जुन चाहिँ relations and functions भन्ने च्याप्टर थियो तिमीले क्लास 11 मा अलिअलि गरेको हो. त त्यो क्लास 11 मा त्यो अलिअलि गरेको प्रब्लमहरु पनि हेर्नु. What is relation, हैन? त्यो रिलेसन के हो, डोमेन के हो, रेन्ज के हो, कोडोमेन के हो, यो चाहिँ तिमीले हेरिराख्नु. त नेक्स्ट क्लासमा म तिमीलाई रिलेशन्स एन्ड फंक्शन्स गराउँछु. ठीक छ? सो दिस मच इज फर टुडे.